Hello students, welcome back to a new session of mathematics for class 11th. So today I am going to start a new lesson, permutations and combinations. It's a very interesting lesson and very useful in our daily life. Okay. So let's begin with the first topic of this lesson, that is factorial notation. Factorial notation. So before going to the concept of permutation and combination, we should know what is meant by factorial notation. Suppose n is a natural number. Suppose n is a natural number. Then the product of first n natural numbers, the product of first n natural numbers, first n natural numbers is denoted by this notation that is called factorial n. The product of first n natural numbers is denoted by this n factorial. This is the mark of exclamation used for the sign of factorial. So it is n factorial, or it can also be represented by this symbol and n. So this is meant by factorial n, n factorial or factorial n. So what is the meaning of this n factorial? The product of first n natural numbers. Suppose I am writing this 5 factorial. Now here the value of n is 5. So 5 factorial means the product of first 5 natural numbers, the consecutive first 5 natural numbers. So what are the first 5 natural numbers? So 5 factorial means 1 into 2 into 3 into 4 into 5. So it is the product of first 5 natural numbers, or we can also write it in the reverse order, that is 5 into 4 into 3 into 2 into 1. Okay, and its value is, just multiply it, you will get 20, then 60 to the 120, it is 120. So 5 factorial is equals to 120. So once again, what is meant by n factorial or factorial n? It is the product of first n natural numbers, first n consecutive natural numbers. Clear? That means if it is given as 5 factorial, then we have to multiply all the natural numbers up to 5, that is 1 into 2 into 3 into 4 into 5. Generally in this factorial notation we will expand it in the reverse order. So generally we will write 5 into 4 into 3 into 2 into 1, and its value is, just multiply it, it is 120. Okay. Now we will see what is the value of 1 factorial. 1 factorial. So what is meant by n factorial? The product of first n consecutive natural numbers. So here it is only 1 factorial, so the value of n is 1, so it is equals to 1. There is only one natural number here, that is 1. Now what is the value of 2 factorial? 2 factorial is equals to 2 into 1, the product of first 2 natural numbers, that is 1 into 2, but I am writing it in the reverse order. So it is better to write in the reverse order. To up to 1 you have to write, so 2 into 1, and that is equals to 2. Next, 3 factorial. What is the value of 3 factorial then? It is 3 into 2 into 1, the product of first 3 natural numbers, that is equals to 3 into 2 into 1, that is 6. Okay. Next, 4 factorial. 4 factorial can be written as 4 into 3 into 2 into 1, and that is equals to 4 3s are 12, 2s are 24 into 1, that is 24. Okay. And I told you 5 factorial. What is 5 factorial? That is 5 into 4 into 3 into 2 into 1, and that is equals to 120. Okay. 6 factorial. 6 factorial is equals to 6 into 5 into 4 into 3 into 2 into 1, and that is equals to, now it is 5 factorial. So 5 factorial is 120. This 6 factorial, listen very carefully, this 6 factorial can be expressed as 6 into, now it is 5 into 4 into 3 into 2 into 1. So we can write this 5 into 4 into 3 into 2 into 1, that means it is the product of first 5 natural numbers. So we can write it as 5 factorial. Okay. 6 factorial can be written as 6 into 5 factorial. So it is 6 into 120. We know the value of 5 factorial, that is equals to 120. So 6 factorial can be expressed as 6 into 5 factorial. So it is equal to 6 into 120, and that is equals to 720. So 6 factorial is equals to 720. Clear? Now we can also express this 6 factorial as 6 factorial can also be expressed as 6 into 5 into 4 factorial. Is it? 6 into 5 into 4 factorial. Why? Because this 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. Now from 4, I am taking from 4, if it is 4 into 3 into 2 into 1, then we can write this 4 into 3 into 2 into 1 as 4 factorial. Is it? So 6 factorial can be expressed as 6 into 5 into 4 factorial. So in this way we can also express 6 factorial as 6 into 5 into 4 into 3 factorial. So if we have to stop anywhere in this natural number, then we can stop it using the factorial sign. Okay. For example, if I am writing this 9 factorial as 9 into 8 into 7 factorial, then it is also correct. 9 factorial can be written as 9 into 8 into 7 factorial. Actually, what is the meaning of 9 factorial? It is the product of first 9 natural numbers. That means 9 into 8 into 7 into 6 into then 5 into 4 into 3 into 2 into 1. So this 7 factorial, if we expand this 7 factorial, we will get 7 into 6 into 5 into 4 into 3 into 2 into 1. So that is 7 factorial. So this 9 factorial can be expressed as 9 into 8 into 7 factorial, or this 9 factorial can also be written as 9 into 8 factorial. So in this way we can write any factorial for natural numbers. Okay. Now let us see how to write the value for n factorial. N factorial. So n factorial is equals to, first we have to write n, the same natural number, then into 1 less than this number. If I am writing 6 factorial, that means I am writing 6 into 5 into 4 into 3 into 2 into 1. Is it? It is 6, then 5, 1 less than 6, then 4, then 1 less than 5. Like that we have to write n factorial as n factorial is equals to n into n minus 1 into n minus 2 into dot 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 and so on into the last number will be 1, and before this 1 there will be 2, and before this 2 there will be 3, like this. So n factorial can be written as n into n minus 1 into n minus 2 into dot 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 and so on, and into 3 into 2 into 1 up to 1 we have to write. So it is written in the reverse order, that means product of first n natural numbers, the product of natural numbers from 1 to n. Okay. So listen carefully, this n factorial can be written as n into n minus 1 whole factorial. Is it? Now I am stopping this at n minus 1. Okay. So this is the value of n minus 1 whole factorial. Clear? Like it is the value of 5 factorial. So this 6 factorial can be written as 6 into 5 factorial. So likewise this n factorial can be expressed as n into n minus 1 factorial, or we can also write this n factorial as n into n minus 1 into n minus 2 factorial. So we can stop anywhere in this. So if we write n factorial is equals to n into n minus 1 into, if we have to stop at n minus 2, then we have to write n factorial is equals to n into n minus 1 into n minus 2 factorial, like this. Okay. So this is one important result, that is n factorial can be expressed as n into n minus 1 factorial. Now very important result that we should know for calculations, we should know the value of 0 factorial. 0 factorial, but 0 is not a natural number here. As this factorial is defined for natural numbers, this n is a natural number. So listen carefully how to find the value of 0 factorial. What is the value of 0 factorial? Now we have one result, that is n factorial is equals to n into n minus 1 whole factorial, where n is a natural number. Clear? Now how to find 0 factorial using this result? Here this n minus 1 factorial, from this result n minus 1 factorial can be written as n factorial divided by n. N minus 1 factorial is equals to n factorial divided by n. Now n is a natural number, so if we take n is equals to 1, 1 is a natural number, so we can take n is equals to 1. Now put n is equal to 1 in this relation, that is we will get in the LHS it is 1 minus 1, n is equals to 1 means it is 1 minus 1 whole factorial, and that is equals to n is 1, so we will get 1 factorial divided by n1, that is 1. So 1 minus 1, now it is 1 minus 1 whole factorial. So 1 minus 1 can be written as 0, and it is the symbol of factorial is there. So it is 0 factorial, that is equals to, what is the value of 1 factorial? That is 1, and denominator is 1, so again it is 1. That means the value of 0 factorial is equals to 1. The value of 0 factorial is equals to 1. It is very important result. Actually this factorial is defined for natural numbers, but we need the value of 0 factorial during calculations. So the value of 0 factorial is equals to 1, and the value of 1 factorial is also equals to 1. So you have to remember this result. So here 0 factorial is defined as 1. Okay. Now I am asking one question, listen carefully. Is 2 factorial plus 3 factorial is equals to 5 factorial? Is it true? Is 2 factorial plus 3 factorial is equals to 5 factorial or not? So let us check. What is the LHS here? Here LHS of this expression is 2 factorial plus 3 factorial. So what is the value of 2 factorial? 2 factorial means 2 into 1, so that is 2, plus what is the value of 3 factorial? 3 factorial is 3 into 2 into 1, that is 6. So it is equals to 6 plus 2, that is 8. So here the LHS is 2 factorial plus 3 factorial, and that is equals to 8. And what is RHS? RHS of this expression is 5 factorial. And what is 5 factorial? That is 5 into 4 into 3 into 2 into 1. So that is equals to 120. So is the LHS is equals to RHS? No. Here 2 factorial plus 3 factorial is not equal to 5 factorial. So listen carefully, don't add as it is here. That means if it is 2 factorial plus 3 factorial, then don't write it is equals to 5 factorial. Okay. So 2 factorial plus 3 factorial is equals to 8, and whereas this 5 factorial is equals to 120. So here LHS is not equals to RHS. So 2 factorial plus 3 factorial is not equals to 5 factorial. Okay. So similarly, if I am asking whether this 2 factorial into 3 factorial is 2 factorial into 3 factorial is equals to 6 factorial. As we know 2 3s are 6, but is this result is true? 2 factorial into 3 factorial is equals to 6 factorial. Let us check. So what is the LHS here? LHS is 2 factorial into 3 factorial, and the value of 2 factorial is 2, and the value of 3 factorial, that is 3 into 2 into 1, that is 6. So it is equals to 12. LHS is 12. Okay. And what is RHS? RHS is 6 factorial. And what is the value of 6 factorial? That is 6 into 5 into 4 into 3 into 2 into 1. So if we multiply it, we will get 720. As we know that 5 factorial is 120. So 120 into 6, that is 720. So here the LHS is 12 and the RHS is 720. So is the result is true? Is this statement is true? Here 2 factorial into 3 factorial is not equals to 6 factorial. So these are very important properties. So you have to remember all these. Here 2 factorial into 3 factorial is not equals to 6 factorial. So we can't multiply directly here. Okay. We have to find the value of 2 factorial, then find the value of 3 factorial, then multiply it. Then the result will be 12. That is the correct value of 2 factorial into 3 factorial, and it is not equal to 6 factorial. Clear? Now let us take some questions related to this factorial. Okay. So here question is evaluate the value of or simplify, find. Okay. Number 1, 10 factorial divided by 8 factorial. 10 factorial upon 8 factorial. So how to find the value of this? You see here the numerator is 10 factorial and the denominator is 8 factorial. Here the numerator is greater than the denominator and it is in factorial. So if we expand this 10 factorial, then this 10 factorial can be written as 10 into 9 into 8 into 7 into, like that we will get. But you see in the denominator 8 factorial is there. So we can stop at 8 factorial. So we can stop at 8 factorial as the denominator is also 8 factorial. Now it is 10 into 9 into 8 factorial divided by 8 factorial. So we can divide, if 8 factorial is divided by 8 factorial, then it is 1. So we can cancel this 8 factorial. Now it is 10 into 9, so it is 90, very simple. So no need to find the value of 10 factorial, then find the value of 8 factorial. It is better to do in this way, that is we have to write, we have to expand this 10 factorial as 10 into 9 into 8 factorial. You stop at 8 factorial, then the denominator is 8 factorial there. So divide it, you will get 10 nines are 90. Now let us take the second question. It is find the value of 30 factorial divided by 28 factorial. Now how to find the value of this? In the same manner, it is 30 factorial divided by 28 factorial. So if we write 30 factorial, anywhere we will get 28. So we have to stop at 28. That means we have to write 30 into 29 into 28 factorial. Okay. 30 into 29 into 28 factorial, as the denominator is 28 factorial. So write 28 factorial here in the denominator, and 28 factorial divided by 28 factorial, that is 1. So it will be cancelled out. Now it is 30 into 29. Okay. So it is, if we multiply, we will get 3 9s are 27, 3 2s are 6 and 2 8, 870. Okay. So its value is 870. So no need to find the value of 30 factorial, then 28 factorial, then divide it. Okay. So you have to do like this. That means we have to write 30 factorial as 30 into 29 into 28 factorial divided by 28 factorial, that is 28 factorial gets cancelled. So it is equal to 30 into 29, and that is 870. Okay. Now let us take one more question. Evaluate 10 factorial divided by 7 factorial into 3 factorial. Now we have to find the value of 10 factorial divided by 7 factorial into 3 factorial. Okay. So here 10 factorial is greater than 7 factorial. So if we expand, if we write the value of 10 factorial, then we will get 10 into 9 into 8 into 7. So we have to stop at 7, and it is 3 factorial. So we can write the value of 3 factorial there. So it is 10 into 9 into 8 into 7 factorial divided by 7 factorial, the denominator is 7 factorial into 3 factorial. So what is the value of 3 factorial? It is 3 into 2 into 1. Now here the 7 factorial is cancelled out, and 3, it is 3 ones are 3, 3s are 9, and 2 ones are 2, 4s are. Okay. Now it is 10 into 3 into 4. So it is 12 into 10. So it is 120. So here the answer is 120. Okay. Now let us move on to the next question. Evaluate the value of this 11 factorial minus 10 factorial divided by 9 factorial. If the expression is 11 factorial minus 10 factorial divided by 9 factorial, then how to find the value of this expression? So here we can expand this 11 factorial as 11 into 10 factorial. As you see, the denominator is 9 factorial. So we have to stop both 11 factorial and 10 factorial at 9 factorial, as we can write this 11 factorial as 11 into 10 into 9 factorial, stop at 9 factorial. Okay. Then minus 10 factorial. How to write 10 factorial? 10 into 9 factorial, and the denominator is 9 factorial. So in the numerator 9 factorial is common now. So we have to take 9 factorial common. So 9 factorial is common, and we are left with this 11 into 10. So it is 110 minus, here it is 10 divided by 9 factorial. Now this 9 factorial is cancelled out. So it is equals to 110 minus 10, that is 100. Okay, very simple. So in this way we have to solve questions related to this factorial. Now let us see one more question. If x by 10 factorial is equals to 1 upon 8 factorial plus 1 upon 9 factorial, then find the value of x. Find x. So one equation is given here, we have to find the value of x. Again you have to see which is greater here, it is 10 factorial, then 8 factorial, 9 factorial. So the given equation is x upon 10 factorial is equals to 1 by 8 factorial plus 1 by 9 factorial. So if we multiply both sides by 10 factorial, we will get x is equals to, if we multiply by 10 factorial, or this 10 factorial can be multiplied to both of these terms, that is, it is 10 factorial divided by 8 factorial plus 10 factorial divided by 9 factorial. So multiply both sides by 10 factorial, you will get x is equals to 10 factorial divided by 8 factorial and 10 factorial divided by 9 factorial. That implies x is equals to, now it is 10 factorial by 8 factorial. So this 10 factorial can be written as 10 into 9 into 8 factorial, stop at 8 factorial as the denominator is 8 factorial plus, now it is 10 factorial divided by 9 factorial. So where we have to stop now? At 9 factorial. So it is 10 into 9 factorial divided by 9 factorial. That implies x is equals to 8 factorial gets cancelled, and here 9 factorial cancelled. So it is 10 into 9, that is 90, and plus 10 is here, so it is 10. So x is equals to, the value of x is 100, clear. So in this way we have to solve this equation, clear. Now let us move on to the next topic of this lesson, that is the fundamental principle of counting, and it is simply called multiplication principle of counting. Okay. So before going to the definition of this fundamental principle of counting, I will take one example from the real life situation to discuss the fundamental principle of counting. Suppose one boy, Ravi, okay, Ravi has two pants and 3 shirts. Ravi has 2 pants and 3 shirts. Now using these 2 pants and 3 shirts, Ravi has to select one pant and one shirt. So in how many ways Ravi can dress up using this 2 pants and 3 shirts? That means by selecting one pant and one shirt. Can you tell me in how many ways Ravi can dress up with 2 pants and 3 shirts? So let's see. Let's mark the pants as P1, pant number 1 and pant number 2. Okay. Now let's mark the shirts as shirt number 1, shirt number 2 and shirt number 3. So there are 2 pants P1 and P2 and 3 shirts S1, S2 and S3. So in how many ways Ravi can dress up using these 2 pants and 3 shirts? So Ravi has to select one pant. So if Ravi has selected this pant number 1, then with this pant number 1 he can use the shirt 1 or shirt 2 or shirt 3. So pant number 1, shirt number 1 or P1 S2, or Ravi can select P1 and S3. So here there are 3 ways. If pant number 1 is selected, then Ravi can dress up in 3 ways using these 3 different shirts. Okay. If Ravi select this pant number 2, then again using this pant number 2, if we select shirt number 1 and or this shirt number 2 or this shirt number 3. So here he can dress up in how many ways? What are the possible ways? What are the possibilities? Pant 1, shirt 1, that is P1 S1 or P1 S2, or if we select P1 and shirt number 3, so it is P1 S3, or if we select pant number 2, that is P2 and shirt number 1, that is S1 and P2 S2, P2 S3, P2 S3. So there are 6 possibilities. That means he can dress up in 6 different ways using 2 pants and 3 shirts. So here we worked out the total number of possibilities using this figure. So if we select pant number 1, then shirt number 1, that is P1 S1, like that, P1 S2, P1 S3, P2 S1, P2 S2, P2 S3. So there are 6 different ways in which Ravi can dress up. Okay. You listen carefully. There are 2 pants and 3 shirts. So if we multiply this 2 into 3, then also we are going to get 6. That means, what does this fundamental principle of counting states? That if an event can occur in m ways, following which another event, the second event, another event can occur in n ways, then the total number of occurrence, of the event in this order means first event in m ways and the second event can occur in n ways, then the total number of occurrence of the event in this order is m into n ways. So it is the fundamental principle of counting. Okay. Once again, if an event can occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence of the event in this order is m into n ways. That means we have to multiply m and n. Okay, clear? Okay students, let's meet in the next session with some problems of this fundamental principle of counting. Till then, bye bye, thank you very much.